Hey everyone, welcome back. Even though we have been provided with many standard models from the Sklearn library, suppose in your machine learning project, let's say you want to create your own model which can take care of the fit as well as the data transformation. Yes, during that time, knowing how to write your own custom estimator will be a high valuable asset as a data scientist, guys. Hence, in this video, I'm going to show you as how you can write your own custom class with the help of Sklearn Base Estimator. And once you learn this, you'll be able to submit your own model to scikit-learn library itself. That's true, guys. You can submit your own model, or you can also create your own model and productionalize it. So this is very important topic, I can say, in terms of data science. So without wasting much of a time, let's get started. To start with, I'm importing as from sklearn.base import base estimator. And after that, I'm importing my NumPy library and the matplotlib library. So let me just execute this. Okay. Now for the learning purpose, we are going to solve the linear regression equation. We already know as what is linear regression equation. The linear regression equation says y hat is equal to theta naught plus theta 1 x1 plus theta 2 x2 up to theta n xn. Here x1, x2, x3 up to xn refers to input features, and the theta naught, theta 1, theta 2 up to theta n refers to the parameters of this linear regression equation, and y hat refers to the predicted output from a linear regression equation. And to solve this theta, that is to solve these parameters, we are going to make use of the normal equation. The mathematical equation of normal equation says x transpose multiplied with x whole inverse multiplied with x transpose multiplied with y. Here x refers to the input matrix and y refers to the output vector. So this is the normal equation method that we are going to use to solve for my parameters. Now to create our own estimator, I have written a class. And this LR scratch, that this is a new class which I am writing, this custom class inherits from base estimator. And inside this class, I have written the method for fit. This fit takes two values, that is x and y. And using this x and y, I am going to solve the values for theta. So we already know the normal equation. So the theta says x transpose multiplied with x whole inverse multiplied with x transpose multiplied with y. Now before I apply this normal equation, I have to do some transformation on my input data x. So what I have done is I have added as np.concatenate with np.1's x.shape of 0. That means I'm adding the term as 1 to every row present in my input data. The reason because I'm adding this theta naught term whenever I'm solving with normal equation, because that do not get added automatically while solving it. And after transforming my input data x, I'm finding the values of theta with the help of this normal equation which I have already said before. After finding the values of theta, I am printing as training completed. Along with fit method, I have written one more method called predict. This predict method takes the data of xtest. Now inside this predict method, I have transformed my xnew. So xnew is equal to np.c, and here also I have added once as the first term in every instance of my training data. And after that, with the use of the theta, I have found the value of ypred. So ypred is equal to self.xnew of self.theta. And finally, I am returning as ypredict. So let me just execute this. Okay, so I have created my own custom class. Now what I'm going to do is I'm going to define my input data as well as my output values. Here I have defined my x and y as np.arange 1,4 reshape of 3,1. So let me just execute this. And if I display the values of x and y, see the values of x and y are 1, 2, 3 and 1, 2, 3. So what are the values of the parameters? Since I only have a single feature, I can say that the values of the parameter are theta naught is equal to 0 and theta 1 is equal to 1. So let's see whether we are getting the same values for theta or not. As a first step, I'm instantiating my model. So here I have written as LR is equal to LR scratch. And after that, I'm going to call the fit method on my x and y. So I have written as lr.fit x, y. Okay, so I have the output that says training completed. Now let's see what are the values of my parameters. If I just print the values of theta, okay, so I have the value that says 8.88 into 10 power minus 16. As you can see, it is close to 0. Hence, the theta naught term is equal to 0. So this is the theta naught term, and the theta 1 value is 1. So we can see that my machine learning model which I have just written is working as expected. Now let's see whether the predict method is working as expected or not. So here what I have done is I'm calling the predict method with X. So if I just execute this, okay, so I have the output as 1, 2 and 3. So this verifies that my linear regression model which I have just written is working as expected. Now let's test it with some complex data, guys. Here to test it, I have written as x is equal to np.random.rand 100,1 and I have written y like this. Y is equal to 4 plus 3x plus np.random.rand and 100,1. That means I'm adding some random noise. After that, I'm creating a plot. So let me just execute this cell. Okay. So this is how my distribution of input and the output data looks like. As you can see, there are some noise. Now on this data, let's perform the fit. So here I've written as lr is equal to lr scratch and calling the fit method on this x and y. And if I display the values of theta, okay, I have the values of the parameters as 4.22 and 2.9369. So as you can see, the values which is currently is 4 and 3, but due to noise, it has predicted the values as 4.22 and 2.93. That's not bad, isn't it? Now, if I call the predict method on the computed values of theta, I have the values like this. Okay, so we now know as how to write our own custom class. Now the next question that we have to think about is the model or is the custom class that we have just written. So let me open the custom class. So if you observe it over here, can we say that this custom class follows the standard procedures which are expected by Sklearn? No, it does not. So as a next step, let's change our model convention so that it matches the requirement of Sklearn package. So I'll come down. Okay. Now to start with, what I am doing is I'm importing as from sklearn.utils.estimator_checks import check estimator. We are going to use this check estimator to verify whether the model that we have just written from scratch is following the conventions as per the expectation by Sklearn module. And then I'm also importing sklearn.utils.validation, check xy, check array and check is fitted. So these are the validations that I'll be making use of whenever I'm writing my custom class. So let me just execute this. Okay. Now there are some rules that we have to follow whenever we are writing our own custom class. So one of the important rule is all the variables inside the class should end with underscore. Here in this cell, I have written the exact way where it is matching as per the Sklearn convention. So let's analyze this code cell, guys. Here inside this class, I have written the fit method. So inside my fit method, I am sending the values of x and y. And after getting the values of x and y, I am checking the x and y with the help of checkxy function. The reason I'm performing this check because I'm verifying whether x and y has the correct shapes as per the requirement of the model. And after that, I'm defining one more variable. The other variable says self.n_features_in_ is equal to x.shape of 1. The reason I have defined this variable because setting the number of features in the input data, which is a mandatory thing with the new version, that is as per the version of 0.24 of Sklearn library. So this is very important attribute that we have to keep in mind, guys. And after that, here instead of using directly as xp, here I have written as self.xp_ is equal to np.c and I have added the x0 term, in other words theta naught term. So I have added the theta naught term, and after adding the theta naught term, I have found the values of theta as self.theta_ is equal to, I have used the normal equation to solve the values of the theta. Now observe here, guys, wherever I was having as xp, I have replaced it with xp_. Okay. And after that, I have defined the variables as coef_ and intercept_ to find the values of intercept as well as the coefficients for the linear regression model. And then I am printing as training completed. And finally, I am returning the self because this is mandatory whenever we are writing our own fit method. So whenever we are writing the fit method, returning the self is mandatory. And after writing the method for fit, I have written the method for predict, and this predict method takes x_test. And after it receives the x_test, I am checking as whether it has performed the fit previously or not. Hence, I have made use of the function check is fitted. So what it would do is, this will check whether the fit has been already called. So that means if I try to call the predict method before calling the fit, I'll be getting the error. So this is the reason I have used this validation. Now, after it performs that validation, I'm going to validate my input before I send it or before I do the prediction. So to validate my input, I'm making use of check array. So hence I've written as xtest is equal to check array of xtest. And finally, I'm returning as xtest multiplied with self.coefficient plus self.intercept, which is nothing but I'm adding the theta naught plus I'm taking the dot product between all the theta 1 up to theta n multiplied with x1 to xn. So this is what it means, guys. That means I'm performing the matrix multiplication between xtest and the self.coefficient and I'm adding the intercept value. So let me just execute this. Okay, so this has been completed. Now let me instantiate my model. I have instantiated my model as lr is equal to lr.scratch. Now to check whether it matches the conventions as expected by Sklearn library, I have written as check underscore estimator. That means I'm passing the instance of my model to this check underscore estimation function. So let me just execute this. Once I execute this, I have the output that says training completed. That means I don't have any error. So this confirms that whatever the values and whatever the conventions that I have written inside this particular custom class is as per the conventions which are expected by a Sklearn module. I hope this video has been helpful to you guys, and there is one last tip that I want to give you before ending this video. Suppose if you want to have your own parameters while instantiating your model, you can specify those parameters inside the init method of your new class. If you want to see more such videos like this, do let us know in the comment section and we'll be happy to help you guys. Do share the codes of your custom models by specifying in the comment section. So I look forward to see you in the next video.